This is Cameron Chai here from azonano.com, and I'm speaking to Jeremy Warren from Nanosight, and he's going to show us through their nanoparticle analysis system.
Thanks, Cameron. Nanosight have developed a unique technology for detecting and viewing nanoparticles in real time. What we do is use laser light to illuminate these particles in this simple cell, inject the sample into this cell here, put it into a device like this. There's a video camera within this and a microscope here. The particles are illuminated by laser light, but the particles we can detect are between 10 and 100 nanometers, 10 and 1,000 nanometers. So at those sorts of sizes, they're a long way below the resolution of normal light. What we're seeing here is essentially the scatter those particles produce rather than image. And this is an image here. So there's a Nanosight view. And what we see here, this is titanium dioxide. This is a very polydispersed mix of titanium dioxide. The largest particles here are perhaps half a micron, 500 nanometers, but the smallest ones are maybe 60 or 70 nanometers. Now, based on this view and the Brownian motion that we can see here, it's possible for us to make a particle size measure based on the speed of the particles, and that's what we do. So particle by particle, we watch this Brownian motion, and you can see the analysis on the software over here. So here we've got a similar image that's being analyzed. The analytical process follows the center of each particle for several tens of video frames, making this little red track like you can see here, and then it makes a calculation. And the point is that it makes the calculations one at a time for each individual particles. So the particle size resolution that we get with a particle size distribution, and here you can see 0 to 1,000 nanometers superimposed on this view with 100 and a 200 nanometer peak. The point is that the particle size resolution is much greater than you'd get through light scattering techniques, which simply measure an ensemble signal from light scattering, dynamic light scattering, photon correlation spectroscopy. This methodology goes a lot further in producing high resolution, but in addition to that, it allows you to see what you're doing. So it gives our customers a unique insight into nanoparticles and nanoparticle dispersions. Seeing is believing. There you go.
And what sort of applications do people use this system for?
First of all, there are the general characterization guys who use dynamic light scattering all of the time, and what they want is a way of verifying what they're doing, especially when they're looking at complex polydispersed systems. So the results you get from dynamic light scattering for a complex system like this TiO2, you're much better off using Nanosight to qualify what you do. So that's general characterization. The other two most interesting areas for us at the moment are, first of all, the study of toxicity for nanoparticles. Now, the toxicology studies, workers in those areas, need to understand aggregation of the mixtures of nanoparticles that they've got before they begin any of their toxicology studies. If you accept the nano story that essentially when things are in smaller quantities, cut up into smaller sizes, they have novel properties, then you have to start your toxicology work from scratch, even though you understand the toxicology of materials in the bulk phase. So when you begin a nanotoxicology study, especially of engineered nanoparticles, the first question is, do I have an agglomeration here of particles or a nice dispersion? Because the particle size is going to make all the difference to how quickly those particles arrive at a cell wall or move through a mucous membrane. So that's toxicology for nanotoxicology of engineered nanoparticles. And the other area, the third area that's most active for us at the moment, is a counting one. And the counting, we put that top of the list here, counting for us means the ability to count the number of particles in the view that we've described here, and that's relevant for the producers of vaccines. Those producers of viruses essentially use plaque assay techniques at the moment to attempt to measure the quantity or the concentrations of the materials they're producing. And what we're able to do very quickly is produce a count, if you like, a concentration of virus vaccine particles, and also to pick up protein aggregation in their stored samples far earlier than anything else that they've seen so far. So, exciting time for us.
All right, Jeremy, thanks for that interesting presentation, and tell us about your LM10 system.
Okay, well, the LM10 system, this LM20 system here, these systems are essentially robust, easy to use, inject a sample at the right concentration, and as soon as the sample's in there, you see a video image of the particles. Actually taking a reading and producing a result maybe takes about 1 or 2 minutes. It depends upon the complexity and the concentration that you have there.
All right, thanks very much for that, Jeremy.
Thanks a lot.